Excellent. Thanks for coming, everyone. We're going to be talking about WebAuthn today, so how Dropbox supports it for second factor, using it next, what comes next for login, and generally looking forward to telling you about it. So first, a quick disclaimer. I do work for Dropbox on the product security team, and I worked on the WebAuthn project, so that certainly informs my talk, but all opinions are still my own. I'm not actually here speaking on behalf of my employer. With that out of the way, let's start with the quick user story. So let's say I'm working on a presentation. Perhaps I want to get some feedback on it. Could be based on a true story here. Share it with my friend. They receive an email. Might look something like this. Nice blue button to click on. Go ahead and click. What happens? Come to this website, username, password, click sign in. Now I can view the file. So how did this website actually figure out this was my friend, that my friend had access to my slides? Well, it's that password. That was really the only secret part of this. And if we start thinking about what we actually want out of a secret like this that authenticates us to a website, controls our accounts, one key element is that we don't really want to tell it to people. That's kind of a strong secret. You're not telling it to everyone. You're keeping it really restricted to only where it needs to be. And unfortunately, passwords are not so great secrets. Since you're in the passwords track of BSides, you may be familiar with this, but you're always entering them on websites. You're essentially telling this web form, this website, all the time, this is my password, please authenticate me. So this, of course, leads to problems because it relies on me, it relies on all of you to not mess up, to not just once put your password into the wrong place. So if we go back to our example, maybe you're used to putting in a password if someone shares a file with you so you can sign in to your cloud provider of choice. So someone else, an attacker, can rely on that to send you an email that looks like someone is sharing a file with you, looks like it redirected you to the right place, but it's of course really a phishing site. So all of a sudden, your password has been told to the wrong set of people, to the wrong server, to an attacker. They can compromise your account. That's one problem with passwords. The other problem is just that you have too many of them, and we're not actually good at remembering long random strings of letters or numbers. So typically, you might choose an easy to remember password, which often means easy to guess. So with that, you also end up with both phishable secrets, bad secrets, and weak secrets. Now, some smart people thought about this and were like, we can do better. We can add a second secret, second factor authentication. So we're probably mostly familiar with this. You have an authenticator app on your phone. You have a code sent to you over SMS. And this really helps with this second case of having weak passwords or reusing passwords, because now you have this second secret that's a little harder to get at. It's actually separate for each site potentially. Your authenticator app has a separate secret for every single site. Or the SMS infrastructure generates a new one-time code for you on every login. So we have this second secret where the part you're telling, it only works for a little bit. It's one-time use. It's a minute long. So we've reduced the risk here and really helped with this second case of password reuse and weak passwords. But we haven't really solved the problem of phishing. Because that part the part you tell still works. It's still working for a whole minute. So someone can just as easily ask for that part as well as your password if they're trying to phish you. And go ahead and turn right back around and once again gain access to your account. The key lesson here was, though, that computers can actually help us to design stronger authentication schemes. So we had this human problem of not being able to remember passwords. One other solution is a password manager, of course. Or in the second factor case, we can rely on our phone to actually remember those secrets for us. And for phishing, if we want to solve that problem, we can see how a browser might be able to help us with that too. Your browser does actually know the difference between a phishing site and a real site. It might not know which is which, or that one is trying to be a masquerade of the other. But it does know their different origins, their different domains. And so we can actually use that information. The TRTP was a pretty good start, the authenticator apps, because they remembered a different secret for each site for you. And the weak link was really that you had to actually be the one to enter the code into the browser. and there was no guarantee that you were entering in the right place. Instead, we can have our browser talk to our devices directly and handle that for us. As long as we keep credentials scoped to a particular domain, our browser can make sure that phishing sites can never gain access to a real site's credentials, because they're just fundamentally different domains. So enforcing that separation, using our computers, our browser to help us, that's kind of the key idea of what WebAuthn bringing to strong authentication. And then really the rest of the talk see how that actually works, and then how you can build on that to have strong second factor authentication, and even potentially passwordless login, and seeing in general, where do passwords fit into this new world if we have strong authentication with WebAuthn. You can see here kind of a roadmap for what I just said, the rest of our time here, and I'll go ahead and dive in to a bit more detail on what WebAuthn actually is. So we have a nice technical looking specification here, and this is kind of the most specific version of what is WebAuthn. It's a specification by the W3C that outlines a set of browser APIs that websites can use to authenticate users on the web using public key credentials. A great thing about public key credentials is now, remember that secret part, we want a secret that we never tell. Here, the secret never needs to leave the authenticator. Only a public verification part is sent to the server. Of course, the other nice thing about this is those credentials are also going to be scoped to a website, as I mentioned. So if you're looking at the spec, it can be a little intimidating, and it helps to just know first, what's the overall structure of what WebAuthn actually lays out for us. So it's going to give us, as where us would be, say, server developers, it's going to give us two operations here. We can register new credentials to a user, and we can authenticate with them. And we have three main parties who we have to figure out how they're going to talk to each other and how they're going to behave. So we have this server that wants to authenticate users. It's also called the relying party, so you'll see that in the spec. Now, the browser mediates communication between all of these elements, and the authenticator devices themselves. So this could really be kind of anything we'll just see going forward. You were talking about YubiKeys, hardware tokens, also authenticators built into your laptop, maybe a TPM, maybe a fingerprint reader, maybe your phone. So this is kind of a wide class of things. But basically anything that can talk to the browser and actually undertake this protocol. Now, if you're looking at the spec, or you're just getting a bit lost if I talk through things, it's helpful to remember that as a server developer, you can ignore a lot of this. And really, as a user, you don't have to worry about too many of the details. So it depends which angle you're coming in from. But the spec really has to describe, both for all three of these parties, what they need to do. So you can really focus in on, especially at the beginning, the party you're most interested in. So in this case, it would be the server developers. And instead of kind of going more in depth and specifically the messages and protocols, just going to kind of go at a little bit of a higher level of what are some key elements of both of these operations. And that'll set us up for how Dropbox actually deployed WebAuthn and what it looks like for different kinds of these options. So for registration, we're going to generate a request for a new credential on the server. We're going to pass that to the browser, call navigator.credentials.create. This is this new API that WebAuthn specifies. The browser is going to go ahead and take that and pass it off to the authenticator, along with what origin the user is currently on. And then they're going to undertake their own protocol. It's specified some in WebAuthn, but the real detailed specification that looks at this side of things, the browser to authenticator, is called CTAP 2. So that's the one to look at if you're really interested in the hardware side of this. In any case, it'll come back. The authenticator will go ahead and create a new key pair, pass the public key and some other information back to the browser, and the browser will go ahead and pass it back to the server, where it can go ahead and parse and save this credential with whatever user is registering. So next, you've registered a credential with your favorite site. You want to log in. Maybe it's second factor, maybe it's login. In any case, the server is going to go ahead, generate ourselves a request, call this API again. The browser passes that to the authenticator, again with that origin, so it's only scoped to that specific origin. So if you're on a phishing site right now, the authenticator will not see the real site. It'll see the phishing site and won't use the real site's credentials. Then the authenticator signs this request using the saved credential, passes it back to the browser. Browser passes it back to the server, or your JavaScript passes it to your backend, and now you can actually verify the response. So this is, of course, a key piece for security. You have to check that it's for the right origin using the right key pair, that a user has actually, the user you think it is, actually is registered with you. So there's a series of verification steps in the spec for both registration and authentication, actually. They're most important in authentication. For registration, a lot of the information is actually not signed or not as important, because the real security comes here, where you're checking the origin and credentials are correct. That's the overview of how this protocol works. Before we kind of get further, I want to interject. If anyone has been researching WebAuthn and is confused by the names out there, or if you do later, it can be helpful to kind of see at an overarching level like how these different keywords or organizations have interacted in the development of this. So you overall have the FIDO2 project. That's WebAuthn plus the CTAP2 spec, which, as I mentioned, is the piece that describes the hardware-to-browser communication. These actually overlap a lot. They really work together, but they're kind of a collection there that was developed by both the FIDO Alliance and W3C. These came out of some earlier FIDO specs that you may have heard of, U2F, UAF, the hardware parts of those, which is now called CTAP1. So you can see, WebAuthn evolved out of basically U2F and UAF, and CTAP2 is the newer counterpart to CTAP1. So where this gets a little trickier is that you can actually mix and match these. So you can have the browser API, you're calling the WebAuthn browser APIs, but the browser is actually talking over CTAP1, maybe to an old legacy U2F-based authenticator. So there was kind of a lot of care put in actually to how these could all be somewhat compatible as much as possible. What you miss out in that case is some new features of WebAuthn only work if you have a CTAP2 authenticator. So hopefully that helps if you see someone marketing, oh, this is a FIDO2 or a WebAuthn authenticator. It's a hardware device. That means it speaks CTAP2. If you see a website saying, hey, we now support WebAuthn, that means they've moved from the U2F browser APIs to the WebAuthn browser APIs. So hopefully that's, yeah.
Can you move your microphone a little bit? There's a lot of pop.
Sorry. Let's see. Is that better? Not as loud, but yes. Sorry about that. Thanks. Yeah. Great. So recap of this section before we move on. If you were feeling a bit sleepy cat, hopefully you get awake cat for the next section here. But in any case, the kind of essentials are just WebAuthn, lets websites authenticate you with some sort of authenticator device. Authenticator devices could really be anything that talks to the browser over this protocol and can store credentials. And the browser and authenticator are what's working together to make sure a phishing site never gets real site credentials. Now I want to talk about where Dropbox comes in. So if you look at 2014, 2015, Dropbox had second factor authentication, TOTP, SMS, and for all the reasons mentioned, wants to do better. We've seen even still recently the kind of pitfalls of like SMS second factor. There was a recent breach Reddit announced saying, hey, we had SMS 2FA, but attackers were still able to bypass that. It wasn't as secure as we thought. So as a developer at a cloud company like Dropbox, you would say, oh, this U2F thing seems quite promising. Fundamentally, U2F is what actually introduced a lot of the ideas that I've been talking about so far. So if you've been thinking, like, what's the difference? We'll get to that, but they're pretty similar in the fundamentals, especially for second factor authentication. So Dropbox went ahead and implemented that, announced we have security key support, quite exciting. And what happened? Well, some users did adopt it. They improved their security. This is good. Definitely encourage all of you to turn on security keys for whatever sites do support it, whether it's U2F or WebAuthn. But there was limited adoption overall for our user base. It's only supported in Chrome, and later Firefox 58 Plus, but still behind a flag, not on by default. And generally, another key point was that there weren't that many hardware devices that users just already had that they could use for security keys for U2F. You had to purchase, go out and independently purchase something like a YubiKey or any of these other hardware authenticator devices. And so this is a big barrier for getting kind of mass adoption. And what's really hopeful about WebAuthn is kind of taking this initial effort of U2F and getting the whole ecosystem on board, saying we're going to have more and more devices users already have, like their phones, like their laptops, have WebAuthn authenticators built in. We're going to support this protocol in all the major browsers, not just Chrome. So that's really the biggest reason to go from, if you have U2F support and you're thinking about going to WebAuthn, like that's the biggest reason is it's the future. That's where this strong authentication is going. And this might seem at first like, is this just marketing? Is there like, anything of substance to this? Like there also is as well. But it's not to be discounted, this kind of ecosystem adoption, because that's really going to be the thing that actually makes it feasible for users to use this on a broad scale and actually be like the commonplace way of authenticating to sites on the web. It's basically connecting websites to hardware devices in a scalable kind of mass adoption way. Of course, we're not quite there, but that's the hope of the future. And then there are also some differences in the protocol. There's some additions, some new features. So kind of the two main ones are that you have more options over credential creation in WebAuthn. So you have a little more control over what kinds of devices or credentials users might use. And you can also have authentication that works without usernames. It works without needing to say, hey, these are the devices you've registered before. Which do you want to use to authenticate? You can just send a request to the browser saying, please authenticate a user. And it will come back with some sort of cryptographic proof of some user device that they previously registered with you, including their user ID. So with that in mind, if you don't have U2F, a site doesn't have U2F, it's really time to just skip to WebAuthn. There's already more browser and device support, and it avoids some complications we'll get into when you support both at the same time. So I have a quick video here just to kind of demonstrate that there are already starting to be new devices there, which this specifically is going to talk about is showing like Touch ID second factor on a MacBook Pro, so the new Touch ID bar. Today, if you get Chrome beta Chrome and turn on a flag, you can actually register Touch ID as your second factor. And so eventually you can imagine using WebAuthn for that to be your primary login as well, or second factor on other sites. So this is a kind of screencast of what that looks like on the actual Touch ID bar, as well as the prompt that came up. So that's a pretty exciting thing WebAuthn unlocks for you, already coming up in the next couple months. And to see how to get there and how, we had a solid U2F implementation, what really changed. I'm going to go into a little bit just like what is actually new at a little bit more detailed level. So even if you're not, planning to directly do this, hopefully it still can kind of illuminate what really changed here and what WebAuthn is all about on a more detailed level. So in U2F, you had some identifier for your website, app ID. You had, I want to challenge, register request, so it has a challenge to make sure that request is fresh. And you had some registered keys because you didn't want to duplicate people, registering the same device multiple times. And in WebAuthn, it's lined up, color-coded to be what kind of corresponds there. So you have, relying party has an ID that replaces the app ID. You have a challenge. You have some credentials. And then you have a lot of new options. That's the part in purple. So we'll talk about some of those a little later. Signing, also pretty comparable. One new option at the bottom there is user verification. This is a nice addition where you can actually request that an authenticator has done some sort of check that the user who's using it is the one it expects. So if you imagine like a YubiKey, a hardware token, if anyone steals that, they can still just use it and press the button. The button doesn't check that it's actually you pressing it. Whereas you just saw Touch ID, that'll actually look at your fingerprint. So there was some verification by the authenticator there that you are who you say you are. If someone steals my laptop, they can't just use my Touch ID authenticator because they won't have the same fingerprint. So that's a new option in WebAuthn to request. The other thing to look at is that you might see the app ID and the relying party ID are different formats. And this has actually caused us some backwards incompatibility because from the device perspective, since those are different formats, it looks like a completely different website. And since the protocol is pretty privacy preserving across origins and also to prevent phishing, it'll treat those as totally isolated sites and won't let you use credentials from one with the other. So to get around that, so people don't have to all re-register their old devices, there's actually an extension in WebAuthn called the app ID extension, so you can specify a legacy app ID to use so users can still keep using those previously registered devices. but that extension doesn't exist for registration. So if you have a device registered with WebAuthn, it's not going to be usable in older browsers with U2F. But if you have already U2F registered devices, those are going to be usable in both with this app ID extension. So this does have a few confusing edge cases. The main one here, whereas, like let's say you have a user, they had a FIDO U2F key registered and they lost it, so they got a new key. Makes sense. They go in, they register their new key. Now it's on a new browser. We've switched to WebAuthn, so it'll get registered with WebAuthn. And in this case, we'll say they forgot to delete their old key. Now, a little bit later, say they're at a library, they're at a friend's computer, they need to log in and get some file or get something out of their account. They log in on an older browser that only supports U2F. So, if we're using Dropbox in this example, we'll see this and we'll say, hey, they have a U2F registered key, so let's go ahead and prompt them to use that. If they don't have any U2F registered keys, could send a separate error message and say, hey, sorry, your key doesn't work in this browser. But in this case, they do have one that'll work, so let's prompt for that. But now the user sees this, they think, well, I have my security key. I'll tap on my new WebAuthn registered security key. And OK, so what happens? Now it comes back, and it looks like a completely different site to that WebAuthn key, because the app ID is a different format. So it'll say, hey, there's not actually a credential registered that wasn't found. It's not registered. And so if you just present that same error to the user, now it's kind of confusing. They're like, I just registered this key. What do you mean it's not found? So in this case, you can actually detect this might be happening. You can't know for sure. It's possible they just actually did try to use a key that's not registered at all. But if you think it might be happening, you can go ahead and give some other error message explaining this case. So that was something that Dropbox did for that as well. The other thing to think about when you're switching from U2F to WebAuthn is looking at something called attestation. So this is cryptographically verified information about the device. And U2F, it's provided by default. If you have a U2F implementation, you've been receiving this attestation. And it can be useful to see device capabilities, will this device be useful on mobile? Or also, if let's say you have an enterprise deployment and you've given all your employees a particular model of authenticator that you trust, and you only want them to use that one on your internal site, you can actually use attestation to require that. So there's some uses there. And but on broad public-facing sites, there's less need to have it be cryptographically verified or to enforce things like that. So it's actually not provided by default. If you look at what Dropbox actually does here, it does request this information. You'll see do you want to provide your make and model of your key? But it doesn't enforce that it's provided or cryptographically verify it, because there's not a need to actually restrict the devices users are using. It's more to guide the product user experience around warning them if their device won't work on other a mobile device or something like that, or just providing better UI to show what devices are being used. The nice thing about WebAuthn, if you've been thinking, okay, this is great, I'm going to have more authenticators, Touch ID, YubiKey, things like that. Do I have to do a lot of work to actually support these new devices? And the answer is no. It's really nice. The browser actually does almost all of the work, especially if you don't care as much about attestation, because that is one area that can differ between device types. The only other real thing you might have to do is just add support for a new public key, private key signing algorithm. So usually that's just a few lines to translate the WebAuthn version of it to your favorite cryptography library's version of it. So one example is pretty recently Microsoft released Microsoft Edge in a preview edition that integrates Windows Hello, Face Sign-In, Pen Sign-In with WebAuthn. And so to make this work on Dropbox was just a few lines of code to add a new signature algorithm, and then it was ready to go. So if you have a preview build of Windows, you can also try this out for second factor. So now that we have this implementation, new wrapper libraries that choose U2F and WebAuthn based on browser support, tweaked the formats a bit for each case, did all the processing, time to roll out. So it went ahead, rolled out second factor on both Firefox and Chrome. And you generally want to do second factor auth first, not the registration part of it, because if you already have U2F especially, you can always turn off WebAuthn auth and go back to U2F. But if you have people registering new WebAuthn keys, you won't be able to use those with U2F authentication or signing. so it's not compatible that way. So typically you'll roll out your authentication piece first, test it with some internal registrations, things like that, and then when you're feeling solid, go ahead and roll that out. In this case, Dropbox rolled out to Firefox, and later Chrome when WebAuthn was stable in Chrome as well. Most recently, as I mentioned, Microsoft Edge Preview Edition is ready to go. So you might be looking at this fancy new WebAuthn experience and see some link at the bottom that says, hey, can't use your device, want to get a TOTP or SMS instead? And you're thinking, well, okay, that seems like an issue. Couldn't someone just tell me to fall back to those and I'd still be tricked? So the answer is not ideal. I agree. But unfortunately, WebAuthn isn't actually everywhere yet. So hopefully in the future, it'll be able to be WebAuthn only everywhere. But for now, on a mobile app, it's still pretty difficult to get WebAuthn working, but that'll be coming soon. That'll be coming. Dropbox has a desktop app, so that's its own kind of separate piece of work to actually integrate WebAuthn into. Safari still doesn't have support for WebAuthn as well. So this is something that hoping to be coming soon, but still, there has to be a balance between this increased security and just locking people out of their accounts when they need to have access. But if you are determined, you only need to use WebAuthn on desktop, for example, you could sign up for TOTP and then just throw away your TOTP seed. But this, of course, is pretty risky in terms of you would want to really understand where am I able to use WebAuthn devices and where aren't I. So stay tuned here for updates. But that's the current state. So just to recap what Dropbox has done so far, and then what we'll talk about for the last part of the presentation here. Rolled out WebAuthn for second factor. You can too. It's pretty well understood based on people's experiences with U2F, kind of how these flows should work. So generally, pretty good there. There's a few tricky parts if you already have a U2F with this backwards compatibility stuff. If not, just skip to WebAuthn. So that's what Dropbox has done so far. And then now I want to, okay, that's where Dropbox is. Now more of my own opinions of speculating on okay, what comes next? How do you get from the second factor authentication to an actual primary login experience? How do you go passwordless potentially? What's the future of passwords there? So first, just to look at it at a technical level. WebAuthn 2FA is actually pretty useful for validating that you want to do WebAuthn sign-in because at a technical level, they're almost the same. The specification doesn't actually make a hard distinction in its basic operations of registering and signing between the cases. It's really about using the options that it provides you differently in some cases. So one example of this is in authentication or signing. In the second factor case, you would generally always provide this allow credentials field because a lot of older devices, to save space, would offload storage of their private keys to the servers. They would first encrypt them with a symmetric key, and that was the only thing the device had to remember. It encrypted the new private key it generated, and then passed that off encrypted to the server where it could store it. Then the server would pass that back in the allow credentials field, and the device would then, on the device, decrypt it and recover the private key and actually use that to sign. So this was kind of a nice hack to save onboard storage on these little authenticator devices. This, of course, doesn't work if you don't even know who the user is yet. You can't pass in these allow credentials. But WebAuthn and CTAP 2 specify something new called I want a client resident key. So this means that private key is generated on the device and never, it's actually stored on the device. It doesn't need to be offloaded in this way to a server. And then if you do that, you can actually receive a user ID back in the response that lets you see, okay, which user actually tried to sign in here. Of course, you can still also do sign in without passwords, but with usernames. So ask for username first, then look up the keys. And if you're just looking at taking your second factor code and turning it into login code, one thing you might forget is that in the second factor case, you've already authenticated the user with the password. So it might be okay to include something about their account to have better UI. It might make a reasonable trade-off, and you might want to make sure you reassess that trade-off if you're returning it just after a username, because there's really been no authentication done at that point. But the spec itself shouldn't pose a problem here. It's just something to be aware of if you're kind of porting that 2FA case directly to login. Yeah, but in general, these basically the same registration signing operations. The harder part is what policies to set. That's where it gets more interesting, because you want to balance users' choice and like how they sign into their accounts, what devices they want to use, with their account's security and also risk of them locking themselves out of their account. So one example of this is maybe you've gone to a WebAuthn sign-up flow where you want to say, hey, the user doesn't even have to make a password for my site anymore. I'm just going to use WebAuthn. And so your user goes, registers a device with you, registers an account. And maybe they registered the Touch ID bar on their laptop. Well, now they're never going to be able to sign into your site unless they have the same laptop. So if they ever go to a different site, they won't have the same, this is like a platform authenticator is what it's called. They won't have the same platform to use, so they won't be able to authenticate. So in this case, there's clearly a high risk of kind of lockout if they lose that device or they're just somewhere else. So you might want to then say, hey, you need to register like a roaming authenticator is what it's called, and actually force them to register some sort of like hardware token that can be removed and moved around between devices, or maybe eventually like a phone would serve this purpose. Although right now, most of the phone operating systems aren't quite there yet. So that's one example there. The other is that if you have a YubiKey that's just test of user presence is what it's called. It's like you press the button, but it doesn't actually verify the user is who they say. You would want to be hesitant before letting users have that as their only like authentication factor, because it's really easy for that to be lost or stolen. And in the case where it's a second factor, that's not too bad because they also have to know the password. But here, like if someone, if you have login through just plugging in a YubiKey and pressing a button, someone could go ahead and like try that on all of the major sites for like common accounts and just like see what they find. And so it's a bit riskier to have like no form of user verification at all. So those are some examples of policies. The other one I mentioned was like in an enterprise deployment, you might want more control over, say, if you're using biometrics, maybe you don't trust biometrics and you want to say, okay, actually don't use that. Or maybe you only trust certain devices that you've already handed out how their biometrics work. So you can go ahead and use some of the other options in WebAuthn, like attestation, or there's a few other registration options to select different types of authenticators to enforce some of those policies. So kind of just to summarize, really the two main questions are, do you require user verification? I would tend to say you should, otherwise it's pretty risky, but it's still something you could think about. And also, what sort of restrictions on device type, whether it's platform or roaming, whether it's a specific model or brand. In general, for like a large public deployment, you probably don't want to get too in the weeds with having to keep up with all the different devices. But there are cases where certain categories of devices and distinctions based on them would make sense. Another example is like on iOS, authenticators like hardware keys are only going to work if they're Bluetooth enabled, because right now there's no NFC support. So that's so you might want to make sure someone registers a device that's usable on iOS. But that's some questions that would be up to whoever implements it. So we have some ideas of, you've got to set some policies, but it's pretty, it's understood we're working out what the best policies are. We could get to a world where there's definitely, it'll be possible to sign into a lot of websites using WebAuthn without a password. So what happens to the password? What are kind of the use cases that are still hard to know the answer to right now or directly get rid of? So one is recoverability. What happens if you lose access to all your devices? Like something catastrophic happens, there's a fire, or you were carrying everything that authenticated you to a site in a backpack that got stolen. Who knows? You lost access to everything. And how do you get back into your account? So the nice thing about a password is that it's in your head. If you have managed to remember it, and it's possible to remember a few strong passwords, even if it's hard to remember one for every site. It's still in your head. You can use that to log in from anywhere. So if you're without any of your devices, you can fall back to that more easily than what do you do in the WebAuthn case, or in the passwordless case. So there are some solutions for certain cases here. Like you can fall back to your email if you're not an email provider, of course. There's another new specification that's pretty cool that's being developed that's called delegated account recovery. So this is something right now that like Facebook and GitHub support, where you can recover your GitHub account through your Facebook account. And it's actually also like privacy preserving. So the only thing the two providers know about each other is that you have an account on the other provider, but they don't actually know like what the username is or what account it is. So it's a nice privacy preserving way to link accounts for the purpose of recoverability. So you could imagine in the future this is more widespread, and you're able to kind of have one trusted account. Maybe it even has your real physical world identity attached to it, and you can use that one to recover all of your other accounts. Maybe through actually like showing up in person. If it was like a bank, you could show up in person with some other form of identification or a police report or et cetera. You could use the physical world's responses to these kind of catastrophic circumstances to bootstrap your online identity as well. So that's kind of one like future-looking thing you could think about it. But in general, it's we'll have to see kind of how this ecosystem evolves. But at first, it'll at least reduce the frequency and number of passwords that are needed. Because at a minimum, a lot of sites, you're probably fine recovering through an email account or something like that. So you could just have them as WebAuthn only, and if you lose a device, maybe you recover it through something else. The other kind of thing people are exploring in the WebAuthn ecosystem is having better ways to handle like registering, say, a backup device that you could keep somewhere safe. And then if you lose the primary device, kind of automatically transferring all the credentials from the primary one to the backup one in a less painful way than having the user like go to every single site and do it manually, because that's obviously going to be quite painful if you're actually using these for a lot of places. So that's another kind of promising thing that people are looking into. But I think recoverability is one of the biggest reasons that passwords might stick around for a while, just to have this ability to bootstrap from losing all your devices. The other area just to think about is that now that we have something like WebAuthn, what value does the password provide? Like clearly if it's a weak password or something like that, it's not providing much, but it's some additional factor. Like, do you still need it? Is there still a benefit there worth the usability cost? A lot of people, it seems like, are trending towards a no answer here. But I could imagine maybe for a few like sites you're particularly concerned about, or want to, you might make the effort to invest in remembering a strong passphrase in addition to your device. Or the other way this could go is that maybe, instead of using the password directly on the website, you use the password on your device to unlock it. So you have a very strong password for your device. So that's probably better long term, because then that password doesn't need to go over the network, but it's still something to think about. And the implications it has is like, how do we encourage users to like adopt WebAuthn? First, should they adopt it as second factor authentication, or should we just directly say, hey, use this to sign in? Does that answer change if they already have 2FA enabled? If a user already has a TOTP code and they turn on WebAuthn for sign-on, like, do you prompt them to get rid of their TOTP? Do you leave it there? Do you get rid of it for them? So you just want to think through, and I don't necessarily have the answers here exactly, like how much security any of these factors provide when multiple ones are being used. Because obviously sometimes it could be totally redundant and you don't need both. But there may be cases where you actually want these second factors, even in the WebAuthn world. Yeah, so now kind of just want to bring it back to all of you. Say, WebAuthn has kind of ecosystem support to bring, the strong authentication to the masses. Like, browsers are on board, hardware vendors are getting there, but we still need more just websites adopting it, users turning it on, showing that, people actually value it. So it's now on to all of us to kind of push this forward and to push WebAuthn to be more and more adopted. It's relatively like easy and well understood for implementing for 2FA, so go ahead and do it. The login with device, passwordless flows also, seem to be getting closer to at least being tried out places. But the best practices around like usability and policies, we're still figuring that out. So, help figure those out as well. And just generally, we can all look forward to fewer passwords, less phishing, and more account security. So I'll end there if anyone has questions. Thanks. No. Yes.
Thanks. I'm curious if you see the need to either keep track of a whitelist or blacklist of devices in this case, just given that the devices are so new. If you find a vulnerability in one, what have you guys done about that kind of thing? Yeah,
so far we haven't seen the need for that. There haven't necessarily been widespread vulnerabilities that have been publicized for a lot of these. It is a good question and kind of an example of why some of that attestation information is useful sometimes to potentially be able to do that. But it's definitely a big cost that in general you don't want to undertake unless you feel like you have to. So far it hasn't been something that we've, or that I would think is really necessary at the moment. Yeah.
Thank you for the great presentation. The problem spaces that you identified here are problem spaces that I've traditionally seen addressed with password managers, right? Phishing and passwords being shitty. What is the, how do you see those two, how do you see this working with password managers? Like, what is the strategic relationship you envision with this product?
Yeah, it's a great question. Because they do solve some similar problems often, especially if you look at like autofill and relying on your password manager to make sure it's only autofilling on the right domain. So it's certainly possible to imagine one, and some people have talked about this actually, is it's not like necessarily my idea, is to have sort of a password manager, but instead of storing passwords, it stores your private keys for a web and then communicates over WebAuthn. And the advantage there is then you still don't have to have this symmetric authentication with passwords. You can actually have like more usable public key authentication. So servers, there's less risk of a breach of a server because now the only thing there is the public keys. So that's certainly one path that could take to have more adoption in general and maybe be easier to use. I'm not sure how much that'll take off versus just signing in with devices like your phone that you already have. I think there'll probably be a mix of both. Like I'm sure someone will create something like you described. And it'll also be up to websites to decide, do we really care if users are storing keys in hardware versus software? And for many websites, the answer is probably no, actually. Like we're just happy that users are storing secure things somewhere instead of not having secure passwords. But there could be some cases where you do want to actually still enforce some sort of hardware security as well. Yeah.
I have a very similar question to that. Is my business is very interested in WebAuthn, but our challenge is the portability of the keys between devices, because we have entire help desks dedicated to just swapping out replacement laptops.
Yeah.
I know this is more of a higher level thing, but what is your personal opinion of how that portability of these keys should be approached? Because I've seen in the past people have said, "Oh, we'll just store it on the device. It'll be hard locked into a TPM or something, and you'll have to re-register." But we have employees that are probably on 30 different sites, and we can't have them locked to a device like that. So I was just wondering if you could go even further into your thoughts on that kind of problem.
Yeah. Definitely a difficult problem. There are people doing work on it now. I was reading like a cool paper. Someone proposed a scheme to help with this problem, essentially, like you said, where basically you could imagine starting to like sign chains of like have the old device, be able to sign for the new device, and maybe like have that pre-registered or some scheme like that, so the keys can still stay on each device, but you could get some sort of chain of trust. I'm not like describing this in like great detail, obviously, or exactly how it would work, but people are thinking about things like that to help with it. Personally, I guess I don't have a strong opinion on like keys have to be, in hardware to have like improvements over traditional password security. But at the same time, I do like when keys are stored in hardware because then they're less vulnerable to things like malware, which is a bit outside the main threat model I've been talking about. But it is still something that's quite nice to protect your credentials as much as you can. So personally, I'm definitely willing to have a bit of usability cost to have my keys on like something like a YubiKey where they're hard to extract. But at an ecosystem level, then I would hope we would be able to develop some sort of solutions like where maybe you can chain these devices together somehow or have it be a bit easier to automatically re-register a new device using an old device.
Is it okay if I have one more question? Or
yeah.
Now, I've seen so many times, and the first iteration of 2FA is often the SMS, and I also often see websites fall back, say, "Oh, you don't have your key, you don't have this other fancy thing. We'll just have SMS." I know this it's out of scope, but what is the response to how common just fallback to SMS is when it comes to WebAuthn?
Yeah, I think it's really the fact that it's still new enough that SMS just has a broader usability kind of support out there. Like we have a phone, the cellular network will get a text to the user, and that's going to work, whereas maybe their phone just has no way to talk to a WebAuthn authenticator that they have. So it's a big challenge right now to kind of develop things that are both usable in all of these cases and secure. So my ideal would certainly be that you can enforce WebAuthn only, U2F only, and it just takes more work to get there to make sure any users who say opt into that are aware of what it means for what devices they can log in on, and also hopefully pushing all of the hardware vendors or browsers that don't yet support it to support it, so it's not a problem. So WebAuthn will be fairly ubiquitous, and you won't need to have some sort of fallback like that.
Thank you.
No, this gentleman's been waiting in front since the beginning, so it's his turn. Thank you.
It's a quick question, really. Is it possible to identify if the website is using U2F or WebAuthn? Because probably hardware tokens are now, available for both.
Yeah. Yes, so it's possible just by looking at basically the JavaScript APIs they're using. Now, in practice, given how JavaScript code is minified, etc., I'm trying to think if there's a really quick way you could immediately see it. But it's definitely visible to the user because it's code running on their browser. And oftentimes you can look in the network responses and see what the challenge format looks like or something like that, or just search for are they using U2F or navigator.credentials.get. The other way to test it is just actually the easier way, I guess, is in Firefox. You can toggle U2F on, WebAuthn off, U2F off, and see what works. But you might have to do some user agent spoofing too, depending on the site. Yeah. I don't know if that means I should stop.
No, that actually means I have a question.
Oh, excellent.
Yeah. You, by the same token, you've got about 5 minutes. So is there a way to, for example, and I'm noob on this, would it be a good thing if you could have your hardware token but also have a way to back up, so if your hardware token gets destroyed, you can go to your vault and rewrite a new hardware token with the correct data?
Yeah, I think that's definitely one reasonable solution to the problem, with the caveat that now there's a new area to attack on that hardware device, right? If there's some way to back up the keys, malware maybe can also do that. So how do you prevent that? Maybe there's solutions here of putting the device in a certain sort of mode that unlocks this functionality, and then, or pairing them device to device. A device could support that, where you buy two, it automatically pairs itself in some way, and then after that you can't pair it again or something like that. So I think there are ways to work around some of the security implications, but in general it's definitely one possibility. Yeah.
I recently read a write-up of Google's advanced protection, and then they have a titanium version of that or something. Anyway, I think the advanced one requires that you have 2 tokens, and now that I know the difference between WebAuthn and the older UTF, I went and checked, and they're actually supporting UTF, the original FIDO spec, but with Bluetooth, so that it doesn't do the YubiKey NFC. Anyway, I guess sort of generic question, did you have thoughts on Google's approach to that, and that they're not supporting WebAuthn, it looks like, for that higher level account security, and just don't know. Yeah. No, I think it's great. Google Advanced Account Protection, that is kind of a U2F only mode that I think did kind of make some good trade-offs around the usability issues, like forcing users to register a key that is going to be usable by their iOS device because it supports Bluetooth, and Google doing the work to add that support into their apps on the mobile phones
to undertake the U2F protocol from a mobile device. So overall, I think it's a pretty good approach. Clearly, I would like to see it move to WebAuthn to get more browser support on desktop, just generally for all the reasons I've mentioned. I think, when it was released, WebAuthn wasn't ready to be used for this sort of thing. U2F was still really the only thing to use for that sort of thing. So that is why it started there. I think also if you look on like WebAuthn versus U2F support on mobile, there are more existing like mobile code libraries support right now for U2F. It's a little easier to do U2F on mobile than WebAuthn right now, but I think that'll change pretty soon. So I would hope they're moving towards that, WebAuthn, yeah. Cool. I think we're out of time for questions, so thanks so much. I'll be around as well if you have more thoughts. Thanks.